And we're back. Thank you to everyone for coming after lunch. Hope you don't fall asleep during this presentation. Today I want to talk about how blockchains can make AI user-owned. For those who are not familiar with me, I am a co-founder of NEAR, Illia Polosukhin. My background is in machine learning and AI research. I worked at Google Research until 2017. I was working across infrastructure like TensorFlow, as well as natural language understanding. Back in the day, before Gemini, you could ask questions, and there was an AI model trying to respond, reading different articles. Now, one of the challenges we faced there was that models we were using were highly not performant. They couldn't read all the context in the time that Google needs to respond, and so that actually what gave birth to the transformer model, which is a T in GPT. And so I'm one of the co-authors working with a team to actually bring this to life. Now, I left Google to start NEAR as an AI startup. It originally was about using transformers to teach machines to code, which now is called vibe coding. Back then, we had way less compute capacity. There was no even A100s yet. And so we're trying to get a lot more training data for us to train our models. And so we had a lot of users, students around the world who would give us, contribute data in various ways, write some small amounts of code, write some descriptions for code. And we had challenge paying them, right? In China, students don't have bank accounts, they have WeChat Pay. In Ukraine, you need to sell half of your dollars on arrival back in the day. In Russia, PayPal didn't work. And so all of the systems had some kind of challenges. And so we ended up looking at blockchain as a solution to our problem as an AI company. How do we actually facilitate these contributions from different people around the world to our model? And we didn't find anything that would scale and would be cheap enough for our need. And that's how we started NEAR Protocol in 2018. Now, fast forwarding, we're now here with AI evolving faster than ever. We have effectively AGI that is coming closer and closer, where most of the digital work will get automated and physical work is not far behind with robotics. Now, the challenge is whoever controls this AI, whoever decides how you can use it, whoever defines what bias the training data has, whoever defines what safety rules can be applied, controls everything, right? We already have this, I was just checking, 2 Nobel Prizes last year were won by effectively AI. A lot more code has been written by AI. A lot more decisions are going to be delegated to AI as well. And so whoever controls how these AIs are trained will effectively affect all these decisions, all this code, and all these inventions. There's also a paradigm shift on application and user side. We're going from Web 2, where we had converged into this aggregator model, right? We had Google for aggregating all the websites. We had Amazon for aggregating all products. We had social media for aggregating all content. Where we're now seeing this transition where you're starting to talk to, instead of asking these models, you're talking to your AI assistant, and it routes you maybe to this content, but actually tries to answer things directly. Now, the next step is it actually goes and does even actions on your behalf on those different websites, right? It goes and registers for you and books tickets and figures out how to do menial tasks. Now, the interesting step after that going to be where you can trust this AI with more decisions because it has more context, and now it's able to go in directly, for example, talk to AI of the pharma company and figure out the exact medicines, exact proteins that need to be synthesized for you specifically based on your medical data, right? This bypasses 5 or 10 different middlemen, decision makers, everything from FDA to pharma to all of those different entities, including pharmacies, that are right now facilitating how you transacting with medicine. So all of this is the transformation that we see happening with agent network, right? This is going to happen with or without Web3, but as I said, if AI is controlled by a single party, it's effectively this whole system will be controlled by them. Now, there's also just general challenges in AI. One of them is monetization. Right now, if you're building kind of a normal AI company, you effectively have a very scarce resource of compute, and you build a model or you build some agent, you offer this to the users. If this is a good model, you get lots of usage, and now you run out of compute. You also don't have now capacity to train a new model because you're out of compute. And getting more compute at a good price is actually a pretty long process. Takes time because you only want to get it from few of the providers like Amazon, Microsoft, Azure, or Google, or CoreWeave. And so you actually have and even though there is maybe data centers around the world, you have this challenge. Now, you're also taking all the data risks, all the privacy risks of the users, right? You're handling all the user data as is. Now, the other alternative is you just open source the model, but the problem is it's not sustainable, right? You're not making any money. There's no way to reinvest and train your model, and this is an expensive process. So right now we have like few companies developing this, a ton of people, especially in universities, sitting on sidelines without access to compute. So we have unsustainable model and a very complex kind of logistics of compute and trust on the closed source side. And so there's a lot of kind of challenges there because, again, as a company, you don't trust external data centers because your model is your IP, and if this IP leaks, then you effectively lose your business. And so you don't trust with your model to some external parties. And so this ends up having this kind of lots of problems. One is you only trust few data centers. Data centers don't build that fast. They need a lot of electricity. This is all in kind of some close proximity. There's like few cities kind of in regions in US where right now this is build out happening. Even though there's, again, lots and lots of space with electricity around the world. Which also leads to latency, right? If I'm sitting in Japan and I'm using ChatGPT, I need round trips to Texas. You have data that gets uploaded, and you never know. There's been stories of, for example, Samsung. Their data got leaked to their competitor through OpenAI because they were just using Copilot style product, and their code ends up being in training data for OpenAI model. You have. So this goes to general corporate security, especially if you're handling users' data. This is even more private, right? A lot of legal firms, financial firms are not allowing to use AI on user data because they're afraid that this is gonna leak. And there's the sovereignty question, right? At the end, if I'm a country and I'm using a centralized provider of the models from another country, that country effectively have more power over me, especially when the AI starts to become really big contributor to GDP, big contributor to automation, big contributor to decision-making of the country. So all of these challenges. Now, on top of this, there's kind of this more fundamental safety challenge, right? There's a lot of conversations about, is AI safe? How do we ensure it is? And there's always a reason, we're not gonna open source our model because it's unsafe, and then people get, open weights model and use it. But generally, the problem is the safety is applied very unevenly, right? We don't have kind of a universal way to apply safety rules across all models and how people participate with them. So that's why we formulated a new vision called user-owned AI. It's an approach where AI is optimized for users' well-being and economic success, not corporate profits. And it's built on top of all of the kind of approaches we've built in Web3. So what we want to make sure is everyone has equal access to the models, while the safety applied equally as well, kind of safety constraints, right? Nobody should be able to use it to design nuclear weapon. Nobody should be able to design bioweapon. User data should be preserved in private unless user wants to contribute it to training in return for something. So confidentiality and permissionless is extremely important. We want to know how model is trained. Again, right now, even the so-called open source models are actually not open source, they're open weights. We don't actually know what went into them. And if you don't know what went into them, you don't know what actually bias this model has, right? Is it leaning right or left in US? Is this more pro, some religion? We don't know. You also don't know if there is so-called sleeper agents. Sleeper agents is a special way to train a model where it will have a different behavior under certain conditions. For example, normally when you look at the model, it does behave normally, but when you're using it to build production software, it will actually import some malicious library and effectively infect your production system. So you want to make sure that you know what training data went in verifiably. And so you want to know effectively the whole provenance of training of this model. Now, more importantly, this needs to be a state-of-the-art model, right? Nobody will use some meh model. People will prefer better product over, values. That's always been the case. That's why crypto been so slow to adopt. Now, you want to make sure that this state-of-the-art model has verifiability of data and model training. So we need a whole setup for that, and we need continuous research and improvements, right? Like it cannot be just like, hey, cool, we build one state-of-the-art model and we're done. It needs to be a continuous process of getting state-of-the-art model and research. There's also a very important aspect that if you completely open source, that means that any other closed source lab can take it open source and build on top of it. And so you cannot be at state-of-the-art if you completely open source. So you need to create some asymmetry of information for this to be really true. So we introduced a solution called Decentralized Confidential Machine Learning at NVIDIA GTC. It's really about creating a platform for this kind of user-owned AI and the roadmap how we can get there. So it's really about creating verifiable and confidential computing that can be run anywhere in the world. Nodes can join it. That allows to monetize models as well as train fine-tune models in a verifiable way, and it offers a safety tooling that is kind of applied to everyone, and nobody can get privileged access to the models. How does this work? Well, first, it's built on top of trusted execution environments. So as of about a year ago, NVIDIA has enabled a confidential computing mode on their GPUs that works with Intel, AMD, and ARM kind of T environments, and so which themselves have improved, at least Intel's and ARMs have improved since the past. And this environment itself allows to effectively run computing in a vault, right? In such a way that whoever even owns the computer is not able to access it directly. It now has GPU enabled, and interestingly, it has this verifiability property that this code is running on this computer, it ran this data, and only this compute was run on this data, right? Meaning you can guarantee that after the running on my data, it will delete it and will never, store it or use it again. So you have this interesting privacy confidentiality properties that you actually don't get even from some of the FHE solutions, and definitely don't get with ZK and other kind of traditional methods. Now, we all put it together into what we kind of this decentralized machine learning cloud, where a user effectively paying on chain for using the models, and then can connect directly to the data, to the compute providers, and run inside their confidential VM different models and different agents. And then there's a lot of pieces that need to be done to kind of tie it all together to ensure liveness of computers, to ensure kind of this model marketplace, but it provides us with this fundamental building blocks for kind of running and building user-owned AI. So we have a number of teams actually building this together. This is not kind of a single team effort in a decentralization spirit. And so we have on the near one side, the team that builds near protocol, they're doing a lot of the key management and kind of encryption, decryption. We have proof of response done to ensure the liveness of nodes. We have Fala doing trust execution environments and confidential inference. We also have teams building on top of it, everything from model training to benchmarking to hosting to RAG to private memory and various data, synthetic data and human labeled data. And this is not a full list, but this is kind of just to show you that this is a whole stack of teams working together. Now, this actually is about deconstructing the AI lab, right? If you go into one of the centralized labs and you open it up, right, there's actually a number of teams that are working together, and they're creating a flywheel of research that's happening inside, right? And so it's important to kind of replicate this process in a decentralized way, opening up ability to actually source talent from everywhere in the world and give them opportunity to participate. So it starts with data, right? You want data acquisition, ability to find better data, clean it and improve it, right? There's a number of techniques and hacks to improve this, as well as using kind of a lower grade models to refine data. There's a synthetic data kind of reprocessing, as well as user contributed data. If users are willing to contribute their data in various ways, which here we can actually guarantee that no single person can actually see the data. It will be cleaned in a very specific way, and then it will be used for training, again, without revealing the individual data. Then we go to pre-training step, right? This is kind of the foundational part. This is about algorithmical improvements to the training process itself. How do you do curriculum learning? How to improve, ability model to learn from less data, from seeing less examples. And then, obviously, research on how do we do it across a distributed and decentralized cluster, right? There's a few teams that have been already working on this and making good progress. And decentralized training is kind of this, I would say, holy grail that people talk about, because it would allow us to actually replicate the whole process, right? If we can do decentralized training on DCML, that means we have this verifiability of where data came from, how it was processed, and then this model artifact effectively came from this data. Now, you can actually keep the model artifact encrypted, right? The weights of the model doesn't need to be open to everyone. They can be encrypted and available in this decentralized network. This actually has all the properties of open weights. You can use it permissionlessly. It's available everywhere. You can use it even on your own hardware, but it's monetizable. Now you can actually charge. So even if you're like, individual developer who just trained a model, you can now charge for using this if it's a good model. And so this solves really this fundamental problem that kind of open source is not monetizable. We're actually kind of changing the game to have, encrypted models with open source to be monetizable, and at the same time have all the properties. And so kind of, if you simplify, there's effectively 3 steps. Step 1, create a market for inference, where you can serve this encrypted models, so anyone can participate, upload their models, and serve it. This solves for this kind of trust problem between model providers, and solves for privacy from companies and users who care. Then we can run benchmarks competitions for different aspects of model building. Refine data better, get reward. Improve the model algorithm, improve the model training, get reward. Run this continuous benchmark effectively, as in you would run these teams internally with OKRs and bonuses on people actually coming up with new ideas. Step 3, put it all together into training, fine-tuning, post-training process, and actually deliver different specialized models for different use cases that people can use that are beating on these benchmarks. And that's really all together, this is how we build this user-owned AI, and this is what we believe is a way to actually ensure we're not going to end up in 1984, Big Brother style world. So this is pretty much it. If you're interested to learn more, follow us on Twitter, at Near Protocol, at @LBlackDragon, and thank you very much for coming. I have time for 1 question, 2 questions.
Hi, Illia. Thank you. Very interesting. The question is, the Near AI, which you're building, can it be rolled out as a wallet itself, so that the agent is a wallet?
So there's a whole kind of, this is really the infrastructure and foundational side. There's also the application side. So on the application side, the wallets, your user wallet will have your private memory, private data for AI. You can have agents running there on your behalf, but you can also run autonomous agents. And autonomous agents have their own wallet. They can enable and transact, and through near chain signatures and intents, they can transact everywhere. They can even start buying physical businesses, hire people, can do all those things, but they're autonomous. So there's effectively a dichotomy between agents that work on behalf of people, behalf of businesses, and autonomous that run kind of themselves. Think of them as fully independent companies that may have shareholders through a token, but effectively run themselves.
Hi, Pedro here. Thank you for the talk. I have a question related to the maturity of your project so far, specifically about the use of TEs and the GPU TEs. Are you guys already kind of using them heavily? And do you have already kind of remote attestation figured out and how this integrates into your whole ecosystem?
Yeah, so the T and confidential inference is live right now through Fala. And then what we're finishing right now is the key management for the specifically recovering keys in TE, so you can decrypt, encrypt models for this kind of serving. But right now you can use confidential inference on open source models. So this is available right now. You can verify all the signatures, kind of NVIDIA, et cetera, and we have key management authority on NEAR that can effectively provision all this. All right, thank you very much.